So now that we've talked a little bit about ions, previous unit, and isotopes, let's take a little bit, just kind of a little review as to how we describe these again. We have knowing what the symbol, we should know what the symbols are for an atom, an ion, an isotope, and knowing how many of each particle in the said substance. So let's say we have something that looks like this, Na. Of course, the 11 would be down here. That's again sodium. So sodium has an atomic number of 11. So we write that in the lower left corner. Let's say it's 23, and let's say it's a 1 plus. Okay. So basically, what I'm showing you is a full chemical symbol, and I want to know. My question to you is, how many protons, electrons, and neutrons in that thing? How many protons, electrons, and neutrons? Well, let's take a look at what these numbers mean. This number right here, to me, I always like to start with the protons. Why? Because the atomic number deals with the, the atomic mass deals with the protons and neutrons, and the ion, the charge, deals with the protons and electrons. So you really need to know your protons. This number right here in the lower left corner is the atomic number, which is your number of protons. I could have ignored putting that 11 all the way in there. Very simply could have erased that 11, but you still would have known, or you still should have known, that there were 11 protons. Why? Because it's sodium. All you gotta do is look at the periodic table, and there's 11 protons. It's right on there. So there are 11 protons. Let me go ahead and just make that nice and bright here with the green. 11 protons in sodium. Now, I guess the next one we could talk about is the electrons. The electrons. Now, in order to figure out electrons, we need to know protons, because the charge lets us know with how many electrons there are. The charge deals with, I don't want to write add, because it's certainly not adding protons and electrons. Deals with protons and electrons. And so you look at your charge, and you need to figure out, is the positive charge or negative charge? Whichever charge it is, that means there's that many more of that type of particle. So if we have a 1 plus charge, as we do in this case, then that means we have one more positive charge than we do have negative charges. So if we see 11 protons, then we must have 10 electrons, because there's 1 plus net charge. Okay, so that's how many electrons. The last one here, again, if I change color, let's grab a different color here. Whoops, why am I not finding it? There we go. Let's grab yellow here real quick, save it. Here in the upper left corner is our atomic mass, or I really should say mass number, which is our protons plus neutrons. And since it's our protons plus neutrons, then we're adding these two together. If I have 11 protons, then I must have 12 neutrons to add up to, of course, that 23 protons plus neutrons. So there's your symbols recognizing what it is. Obviously, you need to be able to go from the, if I give you the protons, electrons, and neutrons, let's say I have something that has, how about 16 protons, 18 electrons, and 17 neutrons. Please write the complete chemical symbol for that thing. Well, protons first. Tells me what it is. You look at number 16. Number 16 is sulfur. We could put the 16 in the bottom left corner. But as soon as we see that we have 16 protons, we know it is sulfur. Electrons. There are more electrons, more negatives than positives. And how many more? 2 more negatives. So that means it has a 2 negative charge. And our protons and neutrons are what adds up to our mass number. And so 16 plus 17 adds up to 33. And so there would be my complete chemical symbol for this substance that has 16 protons, 18 electrons, and 17 neutrons. Okay? Remember, different number of electrons, it's an ion. Different number of neutron, it's an isotope. Okay?